Okay, today we're going to cover Chapter 1, Section 4, which is dealing with absolute value. What we're going to be doing is solving equations with absolute value equivalencies. So the first thing we need to do is kind of recall, what does absolute value mean? Well, remember when we have an absolute value, like absolute value -4, what that means is that when we bring this out, it's going to become +4. Absolute value is changing it from whatever value it is to a positive. So if it is already +4, it would still be 4 when it comes out. Remember, whatever the distance is, this is dealing with distances basically, it's going to be a 4 or a +4 in this case. So what if we had a negative on the outside like this? So negative absolute value 5. So what this means is the number inside is still going to come out as a 5. However, the negative on the outside will track with it and stay in front of it. So you're going, okay, what if I have this? Well, yes, I know you were taught two negatives make a positive, but with an absolute value, it is not the case. Recall, with absolute value, you have to take care of it first. So the absolute value of -5 is 5. And then you carry the negative to the front. So as you can see, these two here are the same answer when they come out, just like these two here are the same answer when they come out. So when you think about it in terms of this, if the negative is on the inside of the absolute value, it's going to become a positive. But if there's a negative on the outside, this is a little trick. They're just trying to throw you off. That means that you're going to have a negative outcome after you evaluate the absolute value. Okay, now we've been brushed up. Let's go through the actual problems. So let's jump ahead. So if you look at example 1, so I'm going to be on page 20 of your note packet. So there's a couple of rules. First off, with absolute values, a regular absolute value, we have one positive, one negative, because we know in all actuality, an absolute value has a positive side and a negative side. The negative side gets wiped out when it comes out for a final answer, but when you're solving equations, it existed at some point, so therefore you have to keep it. All right, so the only time this doesn't play out is when you have it equaling to a 0. Now here's your reason. If you have +0, it's 0. If you have -0, it is still 0. So therefore, it doesn't change anything. So drop the absolute values and set it equal to 0. Now you're ready to solve. So subtract the 12x across, which will give you 3x equals -12. And then just like before, we divide by 3, so x is going to equal -4. All right. So the check step for this is plugging it back in. So the absolute value of 3 times -4 plus 12 should equal 0. And you're going to find that in our check step, it does work. Because -12 plus 12, now whether it's in absolute values or not, is still going to be 0 equals 0. So our check step worked. All right, let's try one now. Like number 2. Now number 2 is very similar to what we've been playing with. So we have y plus 2 in absolute value is equal to 8. So remember what I just said a moment ago. There's always a positive side and a negative side. Now here's the most important part to this. Your absolute value must be totally isolated on the left side. All other numbers must be on the right. Okay, so now that we know that there's one positive and one negative, we're going to rewrite it so that it shows that, dropping the absolute value. So y plus 2 equals 8, and y plus 2 equals -8. This is why it's so important to isolate that absolute value on the left side. Otherwise, the negative is going to mess everything up. Now, we just work it like we normally would. So I'm going to subtract 2. And y equals 6. And I'm going to subtract 2 here, which means y equals -10. Now, if you're wondering, how does this work? Well, let's do a check step. And let's do the positive side first. So we said y was 6. So 6 plus 2 should equal 8. And it does. 8 equals 8. It works out. So now let's put in the negative 10 for y. At this point, you're not believers, I can tell. I'm leaving the absolute value around it because this time it doesn't come out a positive number. So negative 8, absolute valued becomes 8. And lo and behold, the two sides match. Okay, so let's look at the next stage. We've done the first two problems. Now we need to talk about how to graph them. So really the graphing is quite simple. It is just a point on the number line. 1, 2, 3, 4. It's at negative 4. We put a solid dot. So for number 2, we have two things to graph. And I'm going to probably run out of room, but I'm going to do my best here. 1, 2, 3, 4, 5, 6. There's my dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that was close. And it's a negative 10, and we put our dot. So now we have both 1 and 2 graphed. And like I said, we're just putting a dot on the inequality line. So this graph is just showing me where I fall on the number line. And basically, that's it. There's no other reason for this, just to kind of illustrate it. Now, when we get into the next few chapters, you're going to see that there is a purpose to this. But for right now, hang with me. We're just building some blocks right now. So let's look at number 3. So number 3 is a step up. And I don't keep saying a step up, but it's because these are like building blocks. I show you a skill, and then we move it up a little further. And I show you a skill, and we move it up a little further. All right. So for this particular one, we have negative 4, absolute value 7 minus 6k. So what's going to happen is you're going to treat this just like any other thing that you've done in the past. But don't distribute in, not yet. So the first thing is you cannot distribute into an absolute value, but you can change the absolute value into parentheses while you are doing your one positive, one negative. Okay, I told you how to isolate the absolute value, which we do. So let's take and do this. This is going to become negative 4 parentheses 7 minus 6k equals positive 14. So there's the positive side. Over here, do the same thing, only it's going to have a negative 14. All right, hopefully I didn't lose you. So now that you have the positive side and the negative side, let's take and do our distributive property now. So I'm going to have negative 28 plus 24k equals 14. And on this side, I'm going to have negative 28 plus 24k equals negative 14. We work each problem accordingly. So I'm going to add the 28 across here. And I get 24k equals, 42. Divide both sides by 24. And k is going to be a fraction. This is going to become reduced 21 over 12, which is really close to 2, because 24 over 12 would have been 2. So we know we're really close to 2, so keep that in mind when we start to graph this, that you'll use that. On this side over here, once we distribute it in, we're going to take and we are going to add the 28 across. So I get 24k equals 14. And then I divide by 24. So you're just reducing the fraction in this case. So k is going to equal 7 over 12. So both of these ended up being a fractional answer. And you're thinking, how am I going to graph that? Well, folks, think of roughly where they are. We know half of 12 is 6. 7 is just a little bit above it. So when we graph this, we know we are going to have, right there's 1, right there's 2. So if this is 1 and this is 2, both of mine fall within this parameter. So the 7/12 is right about here. It's just a little above half. So 7/12. 21 over 12 is just a little under 2. So I'm going to put that right here, make this 21 over 12. All right, so that's the first 3 graphed. Let's look at our next one. So when I look at number 4, and let me get my number 4 up here. Number 4 is dealing with division to get it across or multiplication. So now we're using the next set of logic. So let me take this off here. All right, so for number 4 on our note packet, we have absolute value d over 3 equals 3. So we know we're starting off with division, and we know the opposite of division is multiplication. But the very first step is to get rid of those absolute values. So I need to do one positive, one negative. So I have d over 3 equals 3, and d over 3 equals negative 3. All right, so to get rid of division, we use multiplication. So I multiply both sides by the denominator. So this becomes d equals 9, and d equals negative 9. Now, I'm not going to graph this one because I think you guys can graph this one pretty easily in the number graph. So let's look at number 5. Number 5 is bumping up the ante here. And I have 3 absolute value 2x plus 5 plus 10 equals 37. All right, so take a moment, write that down. All right, so first thing first, we said you had to isolate the absolute value, and we are clearly not isolated. We have an addition attached to it. So let's go ahead and subtract 10 across before we split it up into 2 sides. So I have 3 absolute value 2x plus 5 equals 27. Now, the next step is going to be to take and write this into 2 parts. One positive, one negative. So I have 3 parentheses, 2x plus 5 into parentheses equals 27. And once again, I'm going to do the same thing, only it's going to be a negative 27 this time. Okay, so first off, we're going to use our distributive property. So I have 6x plus 15 equals 27. We subtract our 15 across, and you get 6x equals 12. So when you divide by 6, you get x equals 2. There we go. Now let's do the next one. So if I have over here, same thing, you're going to get 6x plus 15. Only it's negative 27 this time. Now I'm going to subtract 15 across this time, but my 27 is negative and so is my 15. So I'm going to get negative 42. So 6x equals negative 42. Last step, divide by 6. So x equals negative 7. All right, and just like last time, I'm going to let you be the one to take and graph that. These are not difficult ones to graph. Okay, so this is the end of the first part of 1.4. We're going to do a second part, and it's going to be doing the double-sided or absolute values, and I think that one will be a little more complicated, so I want to give a whole video to that one. So thank you, and tune into the second one. Make sure to complete your first half of your homework on big ideas.